White skin feels like it belongs to northern Europe, the way granite belongs to a mountainside. Ancient, fixed, the natural consequence of the landscape and the light. Most people, if they think about it at all, assume it has been there since the beginning. A slow adaptation to cold gray skies, built into the population over tens of thousands of years of living far from the equatorial sun. That assumption is wrong in almost every detail. The pale complexion associated with Northern Europe today did not exist as a widespread and common trait until somewhere between 3,000 and 4,000 years ago. For the 40,000 years before that, the people living in Europe were darker, substantially darker. And the traits we now associate with Northern European appearance arrived separately from different places at different times and only came together recently. The ground that assumption is standing on is not solid. With this is what actually happened. Every person alive has melanin in their skin. It is not a trait belonging to some people and absent in others. It is a universal feature of human biology, present in every body on Earth, varying in quantity, but never in kind. The darkest skin and the palest skin are both producing the same compound. The difference is how much. And that difference, across the full range of human complexions, is not random. It is the accumulated record of where people's ancestors lived and what the sun did to them there. Melanin's first job is protection. Near the equator, UV radiation hits the skin with an intensity that has no equivalent at higher latitudes, not just stronger in summer, but persistent year-round, relentless, present every day in quantities that do real damage if the skin is unprepared for it. One of the things high UV radiation does is degrade folate, a B vitamin that the body cannot do without. Folate is essential for cell division, for DNA repair, and above all, for the development of a fetus in the womb. A pregnant woman whose folate levels are depleted by UV exposure faces a sharply elevated risk of neural tube defects in her child. Dark skin, rich in melanin, absorbs UV radiation before it can penetrate deeply enough to reach the folate in the bloodstream. It is not decoration. It is a shield, and at the equator, you need it. Move north, and the equation changes. UV radiation at higher latitudes is weaker, not just in winter, when the sun sits so low on the horizon that its rays pass through the thickest possible slice of atmosphere before reaching the ground, but across the whole year. The shield that is essential at the equator becomes, in certain respects, a liability. Because melanin does not only block damaging radiation, it also blocks the UV that the body uses to manufacture vitamin D. Vitamin D is made in the skin. When UVB radiation, the shorter, more energetic wavelengths of ultraviolet light, hits the epidermis, it converts a compound already present in the skin into the precursor of vitamin D3, which the liver and kidneys then process into the active form the body uses. Dark skin, heavy with melanin, absorbs UVB before it can do this work. A dark-skinned person at a northern latitude, under weak winter sun, produces far less vitamin D from skin exposure than a lighter-skinned person in the same place. In the right circumstances, this matters enormously. For bone development, for immune function, for the health of children growing up through northern winters on diets that provide little vitamin D from food. This is the double-edged nature of the relationship. Too much UV and you lose folate, with consequences for reproduction and fetal development. Too little vitamin D synthesis, and you lose something the body depends on for health across a lifetime. The human species, dispersing out of Africa and across every latitude on Earth, has been navigating this trade-off in different bodies under different skies for tens of thousands of years. The range of human skin colors that resulted is not arbitrary. It is the biological record of that navigation. So the conventional story says this navigation is simple. Darker skin near the equator, where UV is high, lighter skin at the poles where UV is low, a smooth gradient in between. And broadly, this is true. But the gradient has gaps in it, places where the expected complexion and the actual complexion of the people living there do not match. The most striking gap involves the people who live closest to the poles. The Inuit of the Arctic and subarctic inhabit some of the highest latitudes on Earth. For months of the year, the sun barely appears above the horizon. UV radiation approaches zero. By the simple logic of the latitude pigmentation gradient, they should be among the palest people alive. They are not. Their skin is considerably darker than that of modern Northern Europeans, despite living in an environment that receives far less UV radiation. The explanation is diet. Traditional Inuit subsistence is built around seal, walrus, whale, and fish, all extraordinarily rich in vitamin D. Their bodies do not need to synthesize it from skin exposure because they are absorbing it constantly from food. The dietary buffer is so complete that the selective pressure for lighter skin, despite the extreme latitude, has never become overwhelming. This is the variable that most explanations of human skin color leave out: diet. The UV melanin vitamin D equation assumes that skin synthesis is the primary source of vitamin D. But it is not the only source. And in populations eating diets rich in animal fat and oily fish, it is not even the main source. When food is delivering what sunlight cannot, the body has no urgent need to modify its relationship with sunlight. The pressure for lighter skin exists, but it is buffered, present but not driving rapid change. The Ice Age hunter-gatherers who lived in Europe for 40,000 years were in exactly this position. Their diet ran heavily on large game: mammoth, reindeer, bison, and horse, with organ meat, marrow, and fat delivering the compounds that their dark skin, blocking the weak winter UV, could not synthesize in sufficient quantities. The latitude should have driven rapid skin lightening. The diet slowed it almost to a standstill, and so they remained dark, not because the selective pressure was absent, but because the dietary buffer was strong enough to keep it from becoming acute. What changes the equation is what happened to the food. When the hunter-gatherer diet gave way to grain, when wheat and barley replaced liver and marrow as the staple of daily life, the dietary buffer disappeared almost overnight in evolutionary terms. Grain contains essentially no vitamin D. A population making that dietary shift at a northern latitude found itself suddenly completely dependent on skin synthesis for a compound it had previously been eating. The selective pressure for lighter skin, which had been weak for tens of thousands of years, became acute, and it drove change fast. That shift happened with the Anatolian farmers, the people who brought grain agriculture to Europe beginning around 7,000 years ago. They carried in their genomes the genetic variants for lighter skin that the hunter-gatherers mostly lacked. And as their descendants spread across Europe, eating grain in northern winters, the selection pressure on those variants became stronger with every generation that lived through a January in Germany or Denmark or Britain on a diet of emmer wheat and very little else. The biology of melanin is not complicated. It is a shield that costs something when the threat it is protecting against is absent. The cost accumulates slowly in populations eating well, fast in populations eating grain. The history of human skin color in Europe is the history of that cost becoming finally and too high to absorb, and of the dietary and demographic changes that made it so. The modern Northern European genome is not the product of one people. It is not the product of two. It is the accumulated result of three entirely distinct populations, each arriving in Europe from a different direction at a different time, each contributing something to the appearance that the modern imagination treats as a single, ancient, unified thing. And no single one of those populations look like a modern Northern European. The appearance only emerges when all three are present in the same genome. And that did not happen until the Bronze Age. The first stream is the oldest. The Western hunter-gatherers, The people who lived in Europe for 40,000 years before anyone else arrived were dark-skinned and, in the Western populations, almost universally pale-eyed. They had been in Europe since the earliest modern human presence on the continent, surviving the Ice Age in the refugia of southwestern Europe, repopulating the continent as the glaciers retreated, living across the full breadth of the land from the Atlantic coast to the Russian plain. They were the baseline. Everything built on top of them came later. What the Western hunter-gatherers contributed to the modern genome is specific. Their most visible legacy is eye color. The pale eye variants that run at near fixation through their populations are now common across all of northern and western Europe, present in the genomes of people whose other ancestry has little hunter-gatherer in it at all. The pale eye variant spread early, spread fast, and is now ubiquitous. Beyond that, the hunter-gatherer contribution to the modern European genome is real but diluted, present in every European, the highest in Scandinavians and the British, lowest in Southern Europeans, but nowhere dominant. The second stream arrived from Anatolia, from what is now Western Turkey, beginning around 7,000 years ago. The early European farmers, as they are now called, were the people who brought grain agriculture westward across the continent, clearing forest, building permanent settlements, and replacing the hunter-gatherer populations they encountered with a demographic thoroughness that left most of Europe predominantly of Anatolian farmer ancestry within a few thousand years. They were dark-haired, brown-eyed, and intermediate in complexion, lighter than the hunter-gatherers they displaced, darker than the modern Northern Europeans their descendants helped produce. The farmer's contribution to the modern genome is the largest single layer in most European populations. In southern Europe, in Sardinia, in the Greek islands, and parts of Iberia, it still dominates. Their most important pigmentation legacy is the skin-lightening variant SLC24A5, which they carried at high frequency from Anatolia, and which spread under strong selection pressure as their descendants farmed grain through northern winters. This variant is now present in nearly every person of European descent alive today. It came from the Middle East. It is the primary genetic source of lighter skin in European populations, and it arrived with people who were not themselves pale. The third stream is the most recent. Beginning around 5,000 years ago, populations from the Pontic-Caspian steppe, the vast grassland stretching across what is now Ukraine and Russia, began moving westward into Europe in a series of expansions that would, within a few centuries, reshape the genetic landscape of the continent more dramatically than anything since the original farmer migration. These steppe people were themselves a mixture of Eastern European hunter-gatherers and Caucasus hunter-gatherers, a combination that produced a genome unlike anything to their west, carrying traits that neither the original European hunter-gatherers nor the Anatolian farmers possessed in the same form. What the steppe people contributed to the modern Northern European genome is substantial. In Northern Europe, in Scandinavia, in the British Isles, in the Baltic states, steppe ancestry accounts for between 40 and 60% of the modern genome. They brought additional skin-lightening variants, complementing the SLC24A5 already present from the farmer migration. They brought the genetic basis for height that makes Northern Europeans among the tallest populations in the world. They brought the KITLG variant associated with blonde hair, which had originated in the ancient North Eurasian population deep in their ancestry. And they brought lactase persistence, the ability to digest milk into adulthood, which spread through their descendants with remarkable speed. Blonde hair deserves a moment's attention here because its origin is the most counterintuitive of all the Northern European traits. Yet the variant most strongly associated with blonde hair in modern European populations, sitting in the KITLG gene, does not come from Western Europe at all. It traces back to ancient North Eurasian populations related to Upper Paleolithic Siberians, deep in the ancestry of the steppe people. The earliest known individual carrying the derived allele comes from the Afontova Gora site in central Siberia. From there, through the complex ancestry of the steppe populations, it entered Europe in the Bronze Age, making blonde hair the most stereotypically Northern European of all appearance traits, ultimately Siberian in origin. Each stream contributes something different. The hunter-gatherers gave the pale eyes, the farmers gave the lighter skin, the steppe people gave the final lightening variants, the height and the light hair. No single stream gives the full package, and the combination only exists because all three streams were eventually present in the same population, mixing, selecting, sorting across the generations of the Bronze Age until something emerged that looked, for the first time, like what we now call Northern European. In a Bronze Age village in what is now Denmark or Northern Germany, a boy is born to parents who carry, between them, all three streams in meaningful proportions. His mother's father was predominantly of steppe ancestry. His father's mother carried substantial farmer ancestry alongside a fraction of the old hunter-gatherer lineage. The boy himself is a mixture. Hunter-gatherer pale eyes, farmer-derived lighter skin, steppe-derived height, and hair color sitting together in a genome that none of his individual ancestors possessed. He looks, more than anyone who came before him, like a modern Northern European. He does not know this. He knows the village, the animals, the fields, now in the particular quality of the winter light. He does not know that his appearance is the product of three entirely separate populations that were living on different parts of the continent as recently as his great-great-grandparents' generation. He does not know that the pale eyes he inherited trace back to a mutation that spread through Ice Age hunter-gatherers. He does not know that the lightness of his skin came primarily from farmers whose ancestors walked out of Anatolia 4,000 years before his birth. He does not know that the particular color of his hair traces ultimately to a population in Siberia that no one in his village has ever heard of. He is simply himself, a person alive in a world that has been assembling his appearance from distant ingredients for thousands of years without anyone's knowledge or intention. The synthesis is complete in her body. It was not complete in her grandmother's. It will be more complete in her grandchildren's. The Northern European appearance is not something that was always there. It is something that arrived piece by piece from very far away, and only recently came together. The three streams are now inseparable in the modern genome. You cannot look at a modern Northern European and point to which feature came from which population. And because the genome has been mixing and sorting and selecting for 3,000 years since the synthesis began. But the history is in there, in the specific variants, in the allele frequencies, in the genetic distances between populations that still reflect the geography of the three original migrations. The past is not gone. It is just very thoroughly mixed. Three populations, three migrations, three contributions to a single appearance, and none of them, on their own, produced anything that looked like what all three produced together. The traits that define the modern Northern European appearance did not arrive together. They did not evolve together. They did not spread through the population together. Each one has its own story, its own origin, its own moment of arrival, and the full combination, all of them present in the same body at the same time. It is so recent that the people who first wore it lived closer to us in time than they did to the hunter-gatherers who painted the walls of Lascaux. The first piece to arrive was the pale eyes. The blue eye variant was already present in European hunter-gatherer populations from at least 14,000 years ago. Carried by the people who repopulated the continent after the last glacial maximum, it fixed at high frequency across the western hunter-gatherer lineage by the time the forests of the post-glacial world were fully established. In the Mesolithic, pale eyes were at their peak frequency. more common in European populations during that period than at almost any point before or since. A man hunting red deer through the birch forests of a warming Europe 8,000 years ago almost certainly had pale eyes. His skin was dark. Then, farming arrived, and something unexpected happened to eye color. As the Anatolian farmers spread across Europe, darker-eyed on average than the hunter-gatherers they were displacing, the frequency of the pale eye variant dropped. The Mesolithic peak became a Neolithic trough. The blue eyes that had been nearly universal in Western European hunter-gatherers became less common as the farming gene pool diluted the hunter-gatherer ancestry. They did not disappear, but for several thousand years, as the farming populations expanded and the hunter-gatherer populations contracted, pale eyes became less frequent across the continent than they had been in the deep Mesolithic past. The skin lightening began its serious work in the Neolithic, carried into Europe by the farmers themselves. There's the SLC24A5 variant, the most important single contributor to lighter skin in European populations, arrived with the Anatolian farmers beginning around 7,000 years ago and spread rapidly as the farming expansion moved westward and northward. By the time the farming populations had covered most of Europe, this variant was widespread across the continent. But widespread is not universal, and widespread is not the same as dominant. Dark skin persisted. Yet even as the SLC24A5 variant rose in frequency, the populations carrying it remained darker than modern Northern Europeans. The variant was present, but the full lightening it contributes to required more time and more selection to drive it to the frequencies seen today. A second skin lightening variant at the SLC45A2 locus tells a different story. It was present in some northern hunter-gatherer populations, the Motala individuals from southern Sweden, dating to around 7,700 years ago. Each carried both major skin-lightening variants, making them among the palest people in prehistoric Europe at that time. But across the rest of the continent, SLC45A2 remained at low frequency until around 5,800 years ago, when something drove it sharply upward. The timing corresponds to the period when steppe ancestry was beginning to enter European populations, and the steppe people, themselves under selection pressure for lighter skin, it carried and amplified the variant wherever their descendants spread. The steppe migrations, beginning around 5,000 years ago, brought the third stream of ancestry into Europe. These people were not pale by modern standards. Their skin was intermediate, lighter than the Western European hunter-gatherers, but darker than the modern Northern Europeans their descendants would help produce. What they contributed was not a finished complexion, but additional genetic material that, and under continued selection pressure in grain farming populations at northern latitudes, pushed the lightening trajectory further and faster than it had been moving before. By the Bronze Age, roughly 4,000 to 3,000 years ago, Europe was a patchwork. In the north, populations with high steppe ancestry and strong selection pressure were lighter than they had been in the Neolithic. In the south, higher farmer ancestry and weaker steppe admixture meant darker complexions persisted, as the proportion of dark-skinned individuals across the continent had dropped from the near total of the hunter-gatherer world. But light skin was not yet dominant anywhere. A man living in Bronze Age Hungary at this time, the individual whose genome shows the full modern combination of light skin, light eyes, and light hair for the first time in the ancient DNA record, was exceptional, not representative. He was the future, but not yet the present. Light hair has its own separate timeline, and it is the most recent of all. The KITLG variant associated with blonde hair first appears in the ancient DNA record during the Neolithic and early Bronze Age, arriving primarily through the steppe ancestry stream. It did not become common in Northern European populations until the Bronze Age was well underway, and it continued to rise in frequency through the Iron Age and beyond. the stereotypically Nordic phenotype, pale skin, blue eyes, no blonde hair, is the last configuration of all the Northern European traits to consolidate. Its full emergence belongs not to the deep past, but to the Iron Age, barely 3,000 years ago. The timeline's endpoint is the most striking fact of all. By the Iron Age, 3,000 to 1,700 years ago, light skin was finally becoming the norm across Northern and Central Europe, nearly as frequent as dark skin in some regions. It was not until this period, well within the age of writing, within the span of recorded history, that the appearance most people associate with the ancient European past actually became common. The Romans, who wrote about the pale-skinned people of the north as a curiosity, were observing a trait that had only recently consolidated in those populations. It was new. No, it felt exotic to them, because it was exotic, a recent development in a population that had been darker within living memory of the oldest stories those northern people told about themselves. The sequence laid out clearly. Pale eyes first in the Mesolithic, carried by hunter-gatherers who were dark-skinned. Then lighter skin, beginning in the Neolithic with the farmers, continuing under selection through the Bronze Age. Then blonde hair, arriving with the steppe migrations and rising through the Bronze and Iron Ages. Then the full combination, pale skin, pale eyes, pale hair, consolidating in Northern European populations during the Iron Age 3,000 years ago at the earliest, and becoming genuinely common only in the centuries that followed. The assumption that this appearance is ancient, that it has been in Europe since the Ice Age, and that it is the natural expression of tens of thousands of years in a cold northern climate, is not even close to correct. The Ice Age Europeans were dark-skinned. The Mesolithic Europeans were dark-skinned. The first Neolithic farmers were intermediate. The Bronze Age populations were still mixed, still darker than the modern average in most regions. The modern Northern European complexion emerged at the end of a long and complicated process, now from ingredients that came from 3 different places at 3 different times, driven by dietary and demographic changes that had nothing to do with the landscape most people imagine when they imagine the deep European past. 3,000 years. And in the span of human presence in Europe, 45,000 years of continuous habitation since the first modern humans arrived, the appearance that defines the modern Northern European stereotype has existed for less than 7% of that time. It is not the baseline. It is the recent exception. And understanding when it arrived and why changes how you think about what it means to look the way Northern Europeans look today. The Bronze Age man in Hungary, lying in his grave with his light skin and his pale eyes and his blonde hair. He is the first person in the ancient DNA record who looks, in the fullest sense, like a modern Northern European. He died roughly 3,500 years ago. The first modern humans arrived in Europe 45,000 years before him. For most of the time between their arrival and his death, nobody in Europe looked like him. He was not the beginning. He was, finally, the end of a very long beginning. And the traits are all present now, in the right frequencies, in the right populations. What comes next is not transformation, but consolidation. The variance rising further, the complexion lightening a little more, the modern configuration settling into the Northern European genome as the normal, expected, unremarkable thing it is today. But the settling took until the Iron Age. And the Iron Age is not ancient. It is practically yesterday. The ground has shifted. The appearance that feels like the oldest thing about Northern Europe is, in fact, one of its most recent inventions. 2 men stand on either side of the continent, separated by 2,000 miles of mountains and rivers and plains. One is in Sardinia, on a limestone terrace above the sea, olive-skinned and dark-haired, tending goats that his family has kept on this island for generations. The other is in Norway, on a fjord in the far north, pale-skinned and fair-haired, and pulling a net from water so cold it numbs the hands within minutes. Both of them are European. Both of them are the product of the same three ancestral streams. They look almost nothing alike. The difference between them is not ancient. It is a matter of proportion, of which stream contributed most to each of them, and when. The Sardinian man carries his ancestry in ratios that would be familiar to a Neolithic farmer from 4,000 years ago. Now, between 65 and 80% of his genome traces back to the Anatolian farmers who reached his island during the Great Westward Expansion. People who were dark-haired, brown-eyed, and intermediate in complexion. His hunter-gatherer ancestry is present but modest. His steppe ancestry is the smallest layer of all. The Bronze Age migrations that swept through the European mainland reached Sardinia weakly and late, leaving only a shallow imprint on an island that was already well populated and relatively isolated. He looks the way he does because his ancestry is predominantly the ancestry of the people who first farmed Europe. The Norwegian man's genome tells a different story. Steppe ancestry in Scandinavia runs between 40 and 60%, among the highest proportions anywhere in Europe. A hunter-gatherer ancestry, routed partly through the steppe populations themselves, adds another layer. The Anatolian farmer contribution, while real and present, is proportionally smaller than anywhere in the south. His height, Northern Europeans are among the tallest people in the world, comes primarily from the steppe stream, whose people were tall and whose descendants carried the height-associated variance into every population they entered. His pale skin and light hair are the product of all three streams converging in high-latitude populations under strong selection pressure. He is what the North looks like when the steppe ancestry is dominant. The gradient between them, the slow darkening of hair and skin and eyes as you move from north to south across Europe, the slow lightening as you move in the other direction, is not the product of thousands of years of separate adaptation to different climates. It is the product of three migrations that moved through the continent at different speeds, reached different regions in different proportions, and mixed in different ratios depending on where the demographic pressures were greatest and the frontiers most permeable. The North looks the way it does because the steppe migrations hit it hardest. The South looks the way it does because the farmer ancestry is deepest there, least diluted by the waves that came after. Move east across the continent, and a third axis appears. The Baltic states, Estonia, Latvia, Lithuania, carry the highest proportions of Western hunter-gatherer ancestry of any modern European population. The hunter-gatherers of Eastern Europe were not fully replaced by the Neolithic expansion the way their Western counterparts were. They persisted longer, mixed more deeply with the incoming farmer populations, and left a stronger genetic signal in the people who live in this part of the continent today. A man in Tallinn carries more of the Ice Age European baseline than almost anyone else in the modern world. His ancestry is, in measurable proportions, the oldest layer in the European genome, the dark-skinned, pale-eyed people who were here before anyone else arrived. The variation across the continent is not a gradient of time spent in different climates. This is the assumption most people make, that Northern Europeans are paler because their ancestors have been further from the equatorial sun for longer, that the pale skin of Norway is simply what happens when people live for tens of thousands of years in Arctic light. The timeline shows this is wrong. The Northern European complexion consolidated in the Iron Age. The Southern European complexion, built predominantly on farmer ancestry, has roots going back further, to the Anatolian Neolithic, in 7,000 years ago. The palest Europeans are not the ones whose ancestors have been in Europe longest. They are the ones whose ancestors arrived most recently from the steppe and whose genomes were most thoroughly reshaped by the Bronze Age migrations. A man in Greece today carries ancestry that maps more directly onto the ancient Aegean farmers than almost any other modern population outside Sardinia. His genome is a window into what the first farmers of Europe looked like. Dark-haired, brown-eyed, intermediate in complexion, the people who built the megalithic monuments and cleared the forests and introduced grain agriculture to a continent that had never known it. The traits associated in the modern imagination with ancient European identity, pale skin, light eyes, light hair, are least common precisely in the populations whose farming ancestors have been in Europe the longest. In Ireland and Iceland, steppe ancestry peaks, running above 50% in many individuals, the highest concentrations in all of Europe. These are among the palest populations on Earth. They are also, paradoxically, among the populations with the most recent deep ancestry outside Europe. The steppe people whose descendants dominate the Irish and Icelandic genomes arrived from the Russian grasslands less than 5,000 years ago. The pale skin of the Irish is not the product of Celtic antiquity stretching back to the Ice Age. It is the product of Bronze Age migrants from the Pontic steppe, whose descendants happen to end up at the far western and northern edge of the continent under the weakest UV radiation in Europe, under the strongest selection pressure for the lightning variants they carried. The geography of European appearance is a map of migration, not a map of climate. And every significant feature of the north-south and east-west variation in modern European complexion, the gradient in skin tone, the distribution of eye color, the decline in hair color from dark in the south to light in the north, reflects the different proportions of 3 ancestral streams in different regions, which in turn reflects where those streams arrived, how fast they moved, and which populations absorbed most of each wave. The landscape did not produce these differences. The movement of people produced them, and the landscape only shaped the selection pressure that amplified what the movements had already distributed. The man in Sardinia and the man in Norway share an ancestry in the abstract, both products of the same 3 streams, both carrying hunter-gatherer and farmer and steppe DNA in measurable quantities. But the ratios are different enough that they look, on the surface, like representatives of entirely different ancestries. Yet that is what 3 waves of migration, arriving at different times in different proportions across an enormous continent, produces. Not a uniform European appearance, but a cline, a smooth gradient of difference that maps almost perfectly onto the geography of those migrations and the centuries in which they moved. Neither of them is more European than the other. Neither of them carries an appearance that is more ancient, more rooted, more authentically of this continent. They are both recent syntheses of populations that were not in Europe at all, or not in the same place, as recently as 6,000 years ago. The difference between them is a matter of which migration left the deepest mark in which place. And that is all it is. The map of European appearance is not a map of deep time. It is a map of the Bronze Age and the Neolithic before it and the faint residue of the Mesolithic beneath that. It was drawn by people moving, yet not by centuries of sitting still under different skies. A boy is born in a Bronze Age settlement in what is now southern Scandinavia, sometime around 2500 BCE. His father has dark hair. Most men in his community do. His mother's hair is lighter, somewhere between brown and a pale golden color that catches the summer light differently from anything his father's family carries. The boy inherits something between the two. There's a hair color that is lighter than most of the people around him, but darker than the pale blonde that will, in his descendants' generation, become more common. He does not think about it. It is simply the color of his hair. Light hair is the last of the major northern European traits to consolidate, and it is the most genetically complex. Yes, skin color is influenced by a relatively small number of large effect variants, SLC 24A5 and SLC 45A2, together account for a substantial portion of the difference between dark and light skin in European populations. Eye color is simpler still. The HERC2 switch explains most of the blue-brown variation. Hair color is different. It is shaped by more than 200 genetic variants spread across the genome, each contributing a small effect. Their combined action producing the full range from jet black to platinum blonde. There is no single blonde gene. There is a constellation of small effects that, in the right combination, at the right frequencies, produces the hair color most associated with the far north of Europe. The oldest individual known to carry one of the key variants associated with blonde hair lived in Siberia near the Afontova Gora site in south-central Siberia, roughly 17,000 years ago. He was an ancient North Eurasian, one of the population that would eventually contribute ancestry to the steppe people who would, thousands of years later, carry a version of his genetic legacy into Europe. The variant he carried, in the KITLG gene, reduces the activity of a growth factor in the hair follicle, producing lighter hair without affecting skin or eye color. He was, as far as the ancient DNA record shows, among the earliest humans known to carry it. The Yamnaya, the steppe people who began moving into Europe around 5,000 years ago, were mostly dark-haired. The ancient DNA from early steppe individuals does not show high frequencies of the blonde-associated variants. The blondism that would eventually characterize northern European populations did not arrive with the steppe migrations fully formed. It developed within Europe over the Bronze and Iron Ages. As the steppe ancestry mixed with the Neolithic farmer and Scandinavian hunter-gatherer populations it encountered, populations that carried their own sets of hair-lightening variants, and as selection and possibly mate preference drove the lighter combinations upward in frequency across generations. Next, the Sintashta culture, the later steppe-derived population that archaeologists associate with the spread of the chariot and the early Indo-Iranian languages, shows much higher frequencies of blonde-associated variants than the earlier Yamnaya. The shift happened within the steppe world before the migrations were complete, as the ancient North Eurasian ancestry within those populations, carrying its Siberian genetic legacy, expressed itself more fully in a gene pool that was mixing, sorting, and changing with every generation. In Scandinavia, where hunter-gatherer ancestry had persisted longer than almost anywhere else, and where the steppe migrations arrived into a population still carrying a strong Mesolithic genetic signal, the combination produced something new. The hunter-gatherer variants for lighter pigmentation mixing with the steppe-derived variants for lighter hair under the strong UV selection pressure of the far north, so in a population eating grain and fish in roughly equal measure. It was a particular set of circumstances that does not exist anywhere else on Earth in quite the same combination. The result, across several centuries of Bronze Age mixing and selection, was the beginning of the blonde frequency that would eventually make Scandinavia the most consistently fair-haired region in the world. By the Iron Age, roughly 3,000 years ago, blonde hair was rising in frequency across northern Europe, but it was not yet dominant even there. A man walking through an Iron Age settlement in Denmark would have seen a range of hair colors: dark brown, light brown, reddish, and blonde, in roughly the proportions that, in some parts of Scandinavia today, still reflect the tail end of that selection process. The blonde majority, where it exists in modern northern European populations, is a product of the last 3,000 years of selection and demographic sorting, not of any single ancestral population arriving with the trait fully formed. Hair color also darkens with age in ways that skin color and eye color do not, which means the frequency of visible blondism in any living population is lower than the frequency of the underlying variants. The blonde child who becomes a brown-haired adult is carrying the same genome at both ages. In populations where the variants are at high frequency, many more people are genetically blonde than look blonde past their 20s. The ancient DNA does not have this ambiguity. It reads the variants directly, regardless of age, but it means that the spread of blondism through European populations may have proceeded faster than visible observation alone would suggest. The boy in the Bronze Age settlement in Scandinavia grows up, has children, and his lighter hair color passes into the next generation in some of them and not others. He does not know that his hair is the product of a variant that first appeared in a man in Siberia 17,000 years before him, that traveled through populations he has no name for, and that has arrived in his own scalp through a chain of ancestry too long and too complex to trace. He knows the color of his hair the way he knows the color of the sky. It is simply what he is. The Nordic phenotype, pale skin, blue eyes, blonde hair together, is the most recent configuration of all. It required all three ancestral streams to be present and mixed, all the major pigmentation variants to have risen to high frequency, and several additional centuries of Bronze and Iron Age selection to drive the blonde hair variants to the levels that make them common rather than merely present. The people who look most stereotypically Northern European today are carrying the most recently assembled combination in the entire 45,000-year history of modern humans in Europe. They are not the ancient baseline. They are the newest thing the continent has produced. A Roman soldier stationed on Hadrian's Wall in the 2nd century AD is darker skinned than most people living in northern England today. This is not a detail about where he came from. He may have been born in Britain, the son of a man born in Britain, his family farming the same valley for 3 generations. It is a detail about when he lived. The pale complexion now associated with the British Isles had not yet become the majority even in the far north of Europe when the Roman Empire was at its height. The lightening was underway, the variants were rising in frequency, but the process was not finished. It would not be finished across Europe as a whole until somewhere in the first millennium AD. This is what the most recent research shows, and it is more striking than most people are prepared for. Here, the genetic variants that produce lighter skin in European populations were selected for, were rising across the Bronze and Iron Ages. All of that is true and was covered in prior videos. But rising is not the same as dominant, and dominant is not the same as universal. For most of the time humans have been in Europe, darker skin was the majority condition. The pale Northern European complexion became the majority complexion in Northern Europe during the Iron Age. It became the majority across Europe as a whole somewhere in the first millennium AD. Within the period of recorded history, within the lifespan of the Roman Empire, within the reach of the earliest written accounts of what European people looked like. The Romans noticed the pale-skinned people of the north. They wrote about them as unusual, as a curiosity, as a physical type, distinct from what they knew in the Mediterranean world. They were right. And the Britons and the Gauls and the Germanic peoples of the far north were, by the late Iron Age, among the palest populations in Europe. The region where steppe ancestry was highest, where UV radiation was lowest, where the selection pressure on the lightning variants was strongest, and where the full combination of traits had consolidated earliest. They were unusual from a Roman perspective because, from a Roman perspective, darker skin was still the norm. The appearance that the modern world treats as the defining European look, the pale skin, the light eyes, the light hair that the Northern European stereotype rests on, was, for most of European history, a minority condition in a small corner of the continent. It became the majority in that corner during the Iron Age. It spread to the rest of Europe as a majority trait only in the centuries that followed. Before that, Europe looked darker, substantially darker. And not uniformly, there was always variation, always individuals carrying more of the lightning variants than others, but the population level average from the Neolithic through the Bronze Age and into the Iron Age was darker than the modern Northern European norm. What does it mean that this is true? It means that the association between European identity and pale skin is built on a foundation that barely existed 1,000 years ago as a majority trait across the whole continent. It means that for the 45,000 years that modern humans have lived in Europe, pale skin has been the common complexion for less than 5% of that time. It means that the deep past of Europe, The Ice Age hunters, the Mesolithic foragers, the first Neolithic farmers, the Bronze Age warriors, was carried by people who were, predominantly, darker than the modern European average. The traits themselves are real. This is not a story about race being a fiction. The genetic variants are real. Their phenotypic effects are real. The differences between populations are real and measurable, and the product of genuine evolutionary history. But the category built on those traits, the idea of a pale-skinned European as the ancient norm, as the deep baseline, as the thing that Europeans have always been, is not supported by the evidence. It is a recent development being projected backwards onto a past that looked different. The pale eyes came first, as in the Mesolithic, worn by dark-skinned hunter-gatherers who would not recognize themselves in the modern European stereotype. The lighter skin came with the farmers, partial and incomplete, insufficient on its own to produce the modern complexion. The blonde hair came with the steppe migrations, polygenic and slow-rising, not common until the Iron Age in most of Europe. The full combination, pale skin, pale eyes, pale hair, consolidated in Northern Europe during the Iron Age and became a majority across the continent only in the centuries that followed. That is the sequence. That is the timeline. It is not ancient. It is practically recent. A man living in Bronze Age Denmark, carrying more of the steppe ancestry than almost anyone to his south, is among the palest people alive in Europe at that moment. His skin is lighter than his grandfather's was, lighter than his great-grandfather's before that. The lightning variants rising in his family's genome generation by generation under the quiet pressure of cold winters and a grain diet and weak UV radiation that demands more from the skin than darker skin can deliver. He does not know he is becoming something. He is simply living, farming, trading, burying his dead in the round barrows that dot the landscape around his settlement. But in his body, the process that began in an Anatolian village thousands of years before his birth is nearing its conclusion. His great-grandchildren will be paler still, their children paler again. The selection pressure does not relent. The variants keep rising. And by the time the Iron Age is well underway, the population in this corner of Europe looks, for the first time, recognizably like the modern Northern European. Not universally, variation persists, darker individuals remain. The population is not uniform, but the average has shifted to a place it has never been before in the entire history of modern humans in Europe. The appearance that feels like the oldest thing about Northern Europe was the last thing to arrive. It assembled itself from three separate streams of ancestry, from three populations that were not in contact with each other as recently as 6,000 years ago, driven by dietary and demographic pressures that had nothing to do with the landscape most people imagine when they imagine the deep European past. The Ice Age hunters did not look like this. The first farmers did not look like this. The steppe warriors who completed the genetic synthesis did not look like this. The modern Northern European appearance is what emerged when all of them mixed in the right proportions under the right pressures. Over enough time, it is real. It is genuinely the product of this continent's particular history. But it is not ancient, and it is not a baseline, and it is not what most people think it is. It is a recent synthesis of very old ingredients. The last chapter of a story that began in Africa, moved through Anatolia, crossed the Eurasian steppe, and finally came together, piece by piece, in the cold northwest corner of a continent that had been home to dark-skinned people for 40,000 years before a pale face became anything like the norm. That is where white skin actually comes from. Not from the cold, not from the ice, from three migrations, a dietary shift, a selection pressure that took thousands of years to finish its work, and a timeline that ends, not in the Ice Age, not in the deep Neolithic, but somewhere in the first millennium AD, when the process finally, unquietly, crossed the threshold from rising to dominant, and the continent began to look the way people now assume it has always looked.